Hi everyone, I am Madam Rosmaya. Welcome to my YouTube channel. In this video, we are going to discuss on past year's STPM physics question on subtopic Newton's laws of motion and frictional forces. Okay, we do question 1A first. So question 1A1, state Newton's second and third laws of motion, 2 marks. A2, a 4,500 kilogram rocket is fixed for vertical launching. The burnt fuel is ejected from the rocket at a speed of 850 meters per second. Calculate the mass of fuel ejected per second so that the rocket starts to move with an acceleration of 7.5 meters per second. So 4 marks. Okay, question 1A1. The Newton's second law states that the resultant force is directly proportional to the rate of change of momentum and occurs in the same direction. And Newton's third law of motion states that for every action there is an equal and opposite reaction. So each of these statements give you 2 marks. Okay, before we continue with question A2, so you need to know what is Newton's second law in detail. So the resultant force represented by the letter F, okay, is directly proportional to the rate of change of momentum. So that's mean here dp per dt. Kp is momentum. So P is momentum equals to mass times volume. So we substitute into here dmv per dt. So we use differentiation rule. So we get m dv by dt plus v dm by dt. Okay, so there are two cases. If the mass is constant, mass of the object is constant, so the dm by dt is equals to 0. So the equation F equals to the resultant force equals to m dv by dt. So another situation is where the v constant. Here forgot, we continue. Dv by dt is equals to a, so we can write as F equals to ma. Okay, so for second situation is where the v constant, velocity constant. So if the velocity constant, so F equals to v dm by dt. This terms equals to 0 because there is no changes in velocity constant. So the equation become resultant force equals to v dm by dt. So for the second question, we are going to determine the mass of the fuel ejected per second. So that's mean we choose the second situation where the case velocity constant, because given here the speed constant 850 meters per second. So we read again the question. A 4,500 kilogram rocket is fixed for vertical launching. So the burnt fuel is ejected from the rocket at a speed of 850 meters per second. So the speed here is constant. Then calculate the mass of fuel ejected per second, which is dm by dt. So that the rocket starts to move with an acceleration of 7.5 meters per second. Okay. So the rocket usually takes before it is lifted off. Okay, it takes some time to lift off, so that the forces upward is larger compared to the mass of the rocket. So at this moment, okay, before the rocket is launched, the mass of the rocket, which is mg, okay, is equals to the thrust of the rocket. let's say we call this thrust of the rocket as F. So this is before the rocket is lift off. And if the F larger than mass of the rocket, so the F is bigger than mg, so that means the rocket starts to launch, okay, with acceleration a, so given by this 7.5 meter per second per second. Okay, so we can form the equation here, F minus mg equals to ma. So we substitute this F. Okay, the force here depends on the mass of fuel ejected per second. So this F is equals to the V dm by dt. Okay, so we substitute into here V dm by dt, okay, minus mg equals to ma. So this is the dm by dt is the mass of fuel ejected per second. Okay. So we substitute the values, mass of the rocket, G 9.81, and the acceleration 7.5. Okay, so, and also V 850 meter per second. So we rearrange this equation. Okay, so dm dt we get 91.6 kilogram per second. So this is the answer for the mass of fuel ejected per second. Okay, so you get 4 marks. 4 marks. Next, we do B, question B. Okay, B1, define coefficient of static friction, 1 mark. Okay, so we do B1 first. Okay, coefficient of static frictions is the ratio of limiting frictional force to normal reaction. In mathematical form, we write mu equals to F per R. So mu is the ratio, mu is the coefficient of static friction. So the ratio of limiting static friction F per normal reaction R. Okay, so we have discussed in the previous lesson that there are two kinds of friction, static friction and another one is kinetic friction. So static friction is the frictional force caused by an applied force at rest before motion. Okay, the block here. And the frictional force, static friction here, depends, is directly proportional to the applied force. So as the applied force increases, the static friction also increases until it reach the value of this value limiting frictional force, okay, the maximum static friction. Then after that magnitude of maximum static friction, so the object here start to move. Then the friction involved is called kinetic friction. In the second animation here shows the kinetic friction. So the frictional force is kinetic friction is the frictional force when an object is sliding in motion. Okay, you get 1 mark. Okay, for this definition for the coefficient of static friction. Okay, next we do B2, question B2. Okay, block. Okay, so before that we read first the question. Block A on a horizontal surface of a table is connected by block B by an inelastic string passing over a light and frictionless pulley. So block C is put on top of block A as shown in the diagram below here. Okay, so block C on top of A. This is block B, so they are connected by a string here. Okay, and here this is the pulley. So the masses of block A and B are 4.0 kilogram and 2.2 kilogram respectively. The coefficient of static friction between block A and the table is 0.25. And we are going to determine the minimum mass of block C to prevent block A from sliding. Okay, 3 marks. So in the question, we are given mass of block A, mass of block B, 2.2 kilogram. So this is mu, coefficient of static friction, 0.25. So we are going to determine the minimum mass of block C to prevent block A from sliding. So means that the system are in equilibrium, stationary, not in motion. So first step, we determine all the forces that act on the system. Okay, we have a mass of block A and C together. Okay, so MA plus MC times G. So the weight of block A and C. Then the weight of block B, MBG. And the reaction force by the table, we call R. Then tension in the string, T. So here also tension in the string, T. They are the same wire, so the T value is the same, action reaction force. Same tension, T because action reaction force, and then no friction on the pulley. Okay. Then lastly is the frictional force. Okay, static friction. Okay, static friction or frictional force in this direction. Okay, so the system are in equilibrium. So therefore, the second step we form equations where the tension here is equals to Fs, static friction, because the object not moving, so they are equal. And also the tension here also equals to Mbg, the block not moving, so they are equals in magnitude. And last, then this T tension is the same. So therefore, Fs equals to Mbg. Okay, static friction equals to weight, Mbg, weight of the block B. Okay, then the R equals to Ma plus Mcg. Okay, and again I repeat here, the block doesn't move, so they are equal. R equals to MAMCG. Okay, next, third step, we solve for MC here, which the question asks for, using simultaneous equations method. Okay, so we are going to use simultaneous equation method and substitute Fs here equals to mu R. Fs is equals to mu R, static friction, and equals to Mbg. Okay, so R is this one. Okay, we substitute this R into here. Okay. Next, we can cancel G. Then we rearrange the equation. So MC equals to MB per mu. Okay, mu bring to the right side, come MB per mu. Then minus MA. Okay, minus MA. So we substitute the value of MB 2.2. Static friction, coefficient of static friction 0.25, and the mass of object A 4 kilogram. Okay, we substitute all the values here into the equation. So the MC is 4.8 kilogram. So this is the minimum mass of block C to prevent block A from sliding. Okay, so we get 3 marks. Okay, done for question B, B2. So we go to B3. Okay, for B3, if block C is lifted, block C if lifted, draw a diagram of forces acting on block A and calculate the acceleration of the blocks, 5 marks. And coefficient of kinetic friction between block A and the table is 0.20. So this is coefficient of kinetic friction. So this means that the block move. They are not in equilibrium state anymore. So they move. The block A move to the right and B downward. So C is lifted. No more C on top of A. Okay, so the objects start to move. So we are going to draw a diagram of forces first and then calculate the acceleration of the blocks. Okay, this is mu k, okay, coefficient of kinetic friction. So 1c is lifted, so the A move to the right and then B goes down. Okay, so this is the direction of acceleration. Okay, next, first step, we determine all the forces that act on the system. Okay, the question asks to draw the diagram of forces. Okay, so we have a weight of the block A. Okay, so MAG. Then weight of block B, MBG. On block A, we have reaction force. Okay, or normal force, R. And we have friction. Okay, friction given by Fk, kinetic friction, and also tangent in the string. Okay, here also tangent in the spring, but the question asks to draw here only. So we draw for both block because we are going to determine A. Okay, acceleration of the blocks. Okay, so second step, we form equation. Okay, so they are no longer in equilibrium, so that means the R equals to MAG. Okay, this is equal because the block A doesn't fly, or the table doesn't collapse. So that means the R equals to MAG. Okay, R equals to MAG. Okay, the block move to the right, so that means MBG. This one first, block B first, block B. So block B going down, so that means MBG is a positive because same direction as A. So MBG is positive, same direction as A. So we follow the sign positive if it follow the direction of A. So MBG and minus T because direction of T is upward. Minus T equals to MA. So the M is M for B. Okay, we separate the body, these two bodies. We use this method to form the equation. Both will accelerate with same A, same acceleration A. So MBG minus T equals to MBA for block B. So for block A, we do the same. Block A is T minus FK because direction of A is this way. So T is positive. So T minus FK. FK is opposite of A, opposite direction of A. So T minus FK equals to MA. So the M here involve block A. Okay, so MA. So we form three equations. Okay, next third step, we solve for this A, okay, using simultaneous equation method. Okay, so we substitute T into the third equation. T minus Fk equals to Ma A. Okay, Mg minus T. Okay, this T is substitute into here. So T is Maa plus K. Okay, Maa plus K. We bring minus Fk to the right side. Okay, become plus. This is kinetic friction. Okay, we substitute into the equation here. Okay, next, F is equals to mu R. Okay, also we convert this to mu R. And then this R we substitute into here. R is MAG. Okay, we substitute into the equation here. So becomes MBG minus bracket MAA plus mu MAG equals to MBA. Okay, next we rearrange the equation. We bring A to this term, A to the right side because we are going to determine A, solve for A. So we bring MAA to the right side, becomes MBA plus MAA. Okay, minus, bring to the right side, become plus. Okay, next we factor out A, because we are going to determine A. So A is equals to the, bring this to the left side. So we get MBG minus mu MAG per MB plus MA. Okay, so we rearrange the equation here, solve for A. Okay, so we get A equals to MBG minus mu MAG per total of MB plus MA. Okay, now we substitute all these values. Okay, mass for A, mass for B, mass for A, kinetic, coefficient of kinetic friction. Here the total of mass A and mass B, and G is 9.81. Okay, we solve for A, we get 2.2 meter per second per second. So this is the answer. Okay, the acceleration of the block is 2.2 meter per second. Okay, so we've done all the questions. So this third question is 5 marks because 2 marks for the diagram of forces and another 3 marks is for to calculate A. Okay?